In this video, we're going to look at the fourth type of conic, which is a hyperbola. We're going to look at its definition, the different parts of a hyperbola, and how we can write the equation of a hyperbola in standard form if we're given certain parts of the hyperbola. So a hyperbola is the set of all points, the difference of whose distance is from two distinct points called foci, that's the plural of focus because there's going to be two of them, is a positive constant. So I've drawn a hyperbola for you. It has two parts. They can open up and down, or they can open left and right. So the two parts of the hyperbola are called the branches. The line that bisects the branches is called the transverse axis. This point right here in the middle is the center. Each branch has a vertex, so I'm just going to put a V there and a V here. And then inside each branch is a focus. So I'll put an F for focus, and then the plural of that is foci. So what gives the hyperbola its shape is based on this definition. The key word is difference. If you take any point on a branch of the hyperbola, so for example, if I want to take this point right here, and I measure the distance from that point to one focus and that point to the other focus, and I subtract those two distances, whatever that difference is, let's say that difference is 3, and then I do that same thing from any other point on the hyperbola, and I do the distance from this point to this focus and this point to this focus, and I subtract, I should also get 3. So that's what gives the hyperbola its shape. The distance to one focus and then to the other subtracted should be the same no matter where you're at on the hyperbola. Okay, so some important information about the hyperbola. The distance from the center to the vertex for a hyperbola, we use the letter A to represent that, similar to an ellipse. The distance from center to focus, we use the letter C, which is also similar to an ellipse. This part right here is different though. The formula that relates all these letters becomes plus instead of minus. So C squared equals A squared plus B squared instead of A squared minus B squared. So A is center to vertex. C is center to focus. But the formula is C squared equals A squared plus B squared. Okay, with a hyperbola, it's important to remember that A is not always going to be larger than B, like it is with an ellipse. Now in this diagram, you can't see B, and you won't see B until we actually start graphing slant asymptotes later. But B is applicable to the graph, and it is in the equation right here. But A is not always larger than B in a hyperbola like it is in an ellipse. Okay, so let's talk about the standard form equations. Since a hyperbola can open up and down or left and right, there are two standard form equations based on which way the transverse axis falls. If the transverse axis is horizontal, which is not like this one, horizontal would mean the transverse axis runs this way, which means your hyperbolas would open left and right, your branches would open left and right. Your formula would look like this: x minus h squared over a squared minus y minus k squared over b squared equals 1. Okay, if your transverse axis is vertical, which is like this one, it would be y minus k squared over a squared minus x minus h squared over b squared equals 1. So these equations are a little bit similar to an ellipse. They equal 1. You have your x minus h and your y minus k's. You've got your a squareds and your b squareds. The thing that's different is your a squared is always first. Your b squared is always second. Those don't move. Instead, what moves is your x and your y. So when it's a horizontal transverse axis, your x comes first. When it's vertical, your y comes first. And also the sign in the middle is now a subtraction because of that key word up here, the difference. Difference means subtract. Okay, so the letters H and K, those stand for the center of your hyperbola. Okay, so those are your standard form equations. And so now that we know those, if we're given some information about our hyperbola, such as where the vertices are or where the foci are, we should be able to write our standard form equations. So let's try a couple of those. All right, use the given information to write the equation in standard form. So for number 1, we're given the two foci at -1, 2, and at 5, 2. And then we're given the two vertices at 0, 2, and 4, 2. It always helps to kind of sketch this out so that you can see exactly what you're dealing with. And so I'm going to do that really quick. Sketching it out just helps you see exactly which way it's going to open. So we have a foci at -1, or sorry, a focus at -1, 2, and at 5, 2, 1, 2, 3, 4, 5, 2, focus. Okay, and then we have vertices at 0, 2, so right here we have a vertex, and at 4, 2, vertex. Okay, remember that your branches always have to open around your focus. So now that we know where our vertices are, we know that our branches are opening like this. So we know we have a hyperbola that's opening sideways, okay, which means our transverse axis is running horizontally right through here, okay? So because we have a horizontal transverse axis, we know that this is the formula we're using, where the x comes first. Okay, so let me go ahead and jot that down. Okay, so to be able to fill in everything that we need the center, because the center is our H and K. Okay, so we need to know what the center is. We also need to know our A. We also need to know our B. Okay, so our center we can easily get. Our center has to split our two vertices evenly. So if we have a vertex at 0, 2, and 4, 2, directly in the middle of those would be right here at 2, 2. Okay, so our center is at 2, 2. So now we know H and K. All right, the next thing we need to do is try to find our A and B. Remember that A is always the distance from the center to the vertex. So if this is our center and this is our vertex, it doesn't matter if you go right or go left, it's going to be the same distance. From here to our vertex, that's 2 units away, so our A is 2. All right, we can't see B from the graph, okay, but we can get B if we know C. So we can find C by going center to focus. So if this is our center and this is our focus, that is a difference of 3 units. 1, 2, 3. So our C is 3. Okay, we can use that formula, C squared equals A squared plus B squared, to find B, since we do know A and C. So since C is 3, we can do 3 squared, that'll be 9. We know A is 2. 2 squared is going to be 4. Sorry, I didn't mean to put equals. That would be a plus right there. Plus B squared. Okay, subtract the 4, so we have 5 equals B squared. So B is going to be the square root of 5. Okay, so now we have the 3 things that we need to write our equation. So let's fill our equation in. X minus 2 squared over A squared. A is 2, so 2 squared is going to be 4, minus y minus k, k is also 2, squared, over b squared. If we square the square root of 5, all that does is take the square root off, and we just get 5, and then equal that to 1. So that would be our standard form equation for that hyperbola. Okay, let's look at number 2. Now, for number 2, we have foci at 0, 4 and 0, negative 4, and vertices at 0, 2 and 0, negative 2. Okay, let's draw that out so we can see exactly how everything's going to line up. Okay, so we have a focus up here at 4, and then a focus down at negative 4, and then a vertice, or a vertex, sorry, at 2, and a vertex down at 0, negative 2. Okay, so this one is actually lining up vertically. So our branches are opening this way to wrap around the focus. So our transverse axis is actually running down the y-axis this time. So it's vertical. All right, so this time the y comes first. It's going to be y minus k squared over a squared. And then it's going to be x minus h squared over b squared equals 1. All right, we need our center, and we need A, and we need B. Okay, so our center, we need to split our vertices in two. We have a vertex up at 2 and down at negative 2, so our center is right here at the origin at 0, 0. Okay, our A, remember, is center to vertex. How far do we have to go to get from our center to one of our vertices? And that's 2 units away, so our A is 2. B, we don't know yet until we find C first. C is center to focus. Okay, if our center's here and our focus is way down here, that is 4 units away to get from 0 down to negative 4, or to get from 0 up to positive 4. 4 units away. So C is 4. A is 2. C is 4. Let's use our formula. C squared equals A squared plus B squared. Okay, so we have 4 squared would be 16. A squared, 2 squared is 4, equals B squared. So if we subtract 4, I keep putting equals and I mean to put plus. If we subtract 4, we get 12 equals B squared, and we square root both sides. So B is the square root of 12. Typically, we would need to branch out that square root of 12 and simplify it, but I'm not going to do that because we know that when we put it back into the equation, we're going to have to square it anyway, and that's just going to take the square root off anyhow, so I'm not going to worry about simplifying that. Okay, so now we have the 3 things that we need to go back into our equation. Since our center, since our HK is 0, 0, when we put the 0, 0 in here for HK, it's going to be like y minus 0 and x minus 0. So that's going to simplify to just y squared and just x squared. So we really have y squared over, and then a squared, that'll be 4. And then x squared over, when we do the square root of 12 squared, it's going to take the square root off, and you're just going to get 12, and then equals 1. And that is standard form for that one.